Okay, so the last thing we want to go over pretty quickly before your lab is just uncertainty and sig figs. So when you're measuring things in the lab, you're going to have uncertainty, and that's what we're going to talk about today. So if you have any kind of uncertainty, it's unavoidable, it's going to happen, and it's just because you're not perfect and the instruments you're using aren't perfect. There are two different things we look at. The first thing we look at is called precision, because we're looking at basically how close are you. So if you make a measurement 20 times, are all 20 very close, or are they kind of very different from each other? And again, like sometimes we'll do experiments where we'll do 3 trials, and that's what you're checking with that. You're doing precision. So like if you if you run the mile every day, and every day you run 6 minutes, which is very fast, good for you, then you would be very precise. Accuracy is usually what students care about, because accuracy is if you're right. So accuracy is comparing it to what it should be, the true value. So the accuracy is often what you focus on more, because like if you're doing a lab, you typically want a low % error. But precision is important too, and they kind of go hand in hand. When you calibrate things, they're going to make things more accurate, and also sometimes it'll actually add precision to it. Typically, I mean, you can have scales that are not accurate at all, but they're very precise. Like 2 years ago, we were doing a lab, and this one group kept measuring a penny, and the scale kept telling them it was 60 grams. Like a penny is like 4 or 5 grams. So the scale was very inaccurate, but it was becoming very precise. Real easy way to remember that is with the dartboard analogy. So if you're very precise and you're very accurate, it means you're going to hit the bullseye over and over and over and over, because you're really good and you always hit the right spot. That is not me, by the way. If you're highly precise but you're not accurate, it means that you're going to hit the same spot over and over and over, but you're not getting it where you want it to be. And this is pretty frequent in science. It's a good thing if you're this way, because that means that there's one issue, and if you can typically fix that one issue, then that means that you would be okay with your situation. This is kind of me bowling. I'm horrible at bowling. I don't bowl very often, but if I bowl, my ball always goes in the left gutter at the same point. So I'm very precise, but obviously I'm not accurate because I don't knock any pins down. If you're low precision, low accuracy, you're all over the place, and this is not the best thing for science, because now we don't know what's going on with you, but we just know you're not doing so hot. And this is much harder to deal with in science, because you don't know really where to attack from. You don't know what to change, and you don't know how to change it. The last one, you have to kind of go off of darts for a little bit. But if you're low precision but high accuracy, it would be something like this, where I would have dots around the edge. And they're obviously not precise. They're not near it or anything. But if I would average these guys, I would end up right in the middle. So if I averaged the guy on the right and the guy on the left, I'd be accurate. And I would average the guy on the top and the bottom, I would be accurate. This sometimes happens in lab, and you think, oh my gosh, I got really good data, when really it's not that great, because your precision was really off, but it just kind of looks that way. So just keep that in mind when you're measuring things. Like, you want to be accurate, but you also want to be precise. And that's why sometimes we have some people where they're the ones that always measure it. Like one person repeatedly measures it. If we check things, we typically check accuracy, and if you're going to check accuracy, you do what's called % error. So you take what you measured in lab, minus the accepted value, and divide by the accepted value, and then we multiply it by 100. It's okay to have a negative % error. It's okay to have a positive % error. All it means, if you're positive, it means you got more than you were supposed to. And if you got negative % error, it just means you were less than you were supposed to. So it's not a huge deal. It's just indicating two different things. And that's okay. You just want to remember that the thing that you measure in lab goes first, and then what it's supposed to be, the accepted value, is on second, and then on the bottom. So we're going to look at some sig figs, and then we're going to go measure things.